Welcome to Tomorrow Unveiled, your weekly deep dive into the foundational shifts happening in artificial intelligence.
This feels like one of those weeks the kind historians will look back on and just mark as a clear inflection point.
Right.
For the last few years, the whole AI story was really about generation. You had chatbots writing, passable poetry and models making these creative but sometimes unreliable images.
A little bit weird sometimes.
A little bit weird. But what the source material compiled by our dedicated research team shows for late December 2025 is this sharp, industry-wide pivot, a pivot toward agency.
Absolutely, and that's the key word, isn't it? Agency. The focus isn't just on how well the AI can generate a response anymore. It's about how effectively it can take complex, autonomous action to achieve a real goal.
Exactly.
We're moving out of that, show don't tell phase and really into the go do era of AI. It's starting to function like a colleague, not just a tool you pick up and put down.
A very capable colleague.
So our mission today on Tomorrow Unveiled is to unpack this massive fundamental shift for you. We synthesized a huge stack of sources. We're talking academic papers, financial reports, corporate announcements, and three major themes really stand out. They're corroborated across all of them.
And that cross-corroboration is so important. It tells us this isn't just one company's press release. It's a real trend.
For sure. So first, we've got these hardware breakthroughs that are literally tearing down the physical walls of computation, specifically solving that long-standing memory wall bottleneck. Second, the entire industry is pivoting strategically, architecturally. Everything is moving toward these fully autonomous agents. They're becoming the default way we're going to interact with intelligent systems.
Right.
And third, well, this rapid progress brings challenges. Major security risks, new legal battles over data, and this fundamental crisis of quality that our team is calling AI slop.
And the consensus across all the sources is just incredibly loud on this.
Yeah.
The focus has moved entirely from just scaling model size, trying to make the brains bigger and bigger, to scaling deployment.
Okay, so making it practical.
Making it practical, safe, and just ruthlessly efficient. And it doesn't matter if that means running a powerful agent on a cloud server for an hour straight, or running a tiny specialized model on a chip inside a device at the edge of the network.
Right.
This push toward embodied AI, where systems take physical or operational action, is being confirmed. We're seeing early small-scale industrial deployments of humanoid robotics in places like semiconductor manufacturing. And that proves it's viable. It marks the true start of this era of generalized purpose AI agents.
Okay, let's start with that hardware revolution then, because, none of the agentic stuff we're going to talk about later is even possible without tearing down these physical constraints of computation.
At this scale, no.
And for years, the big bottleneck holding back models like ChatGPT or Claude, it wasn't the processor speed itself. It was this thing called the memory wall.
The classic choke point, yeah. The memory wall refers to this critical bottleneck where data just cannot move fast enough between the storage, the memory, and the processing units, the chips themselves.
So the processor is sitting there waiting for data.
Exactly. It's starving.
Yeah.
For today's huge language models, which operate on just petabytes of training data and billions of parameters, this data movement speed, the latency, has fundamentally constrained everything.
I think you used an analogy before. If your processor is a race car,
Then the memory wall is the tiny, slow, congested, single-lane road leading to the fuel station. The car is fast, but it can't get fuel quickly enough to actually race.
but the breakthroughs from this past week suggest that road is being, widened, rebuilt into a vertical superhighway or something.
That's a great way to put it.
Our dedicated research team highlighted the first monolithic 3D AI chip. This is a landmark achievement, right? A huge collaboration. Stanford, CMU, MIT, UPenn, all working with Skywater technology. This sounds conceptually massive.
It fundamentally changes the physical architecture of the chip. So instead of laying memory and computing elements out flat on a 2D surface, which forces data to travel these relatively long electrical distances, this design stacks them vertically, like floors in a skyscraper.
Okay, so I'm picturing a high-rise building.
Right. Imagine you have a complex task happening on the 5th floor, but the data you need is stored way down in the basement.
In a normal chip, that data has to take the slow, winding stairwell, which uses a lot of power.
Precisely. In this 3D monolithic design, the key is the integration. They build each new layer directly on top of the previous one using vertical wiring.
And these are the elevators.
They're incredibly fast, very short, dedicated elevators. They move data between the stacked layers at just unprecedented speeds. And the architecture also integrates new kinds of memory, like RAM and carbon nanotube transistors, all in a single process. That's the real technical feat that gets them the density.
Okay, but what did it actually achieve? This wasn't just a theory, right? It was a real thing.
Oh, it was proven on real workloads. The initial hardware demonstrated a 4 times performance improvement over comparable high-end 2D chips.
4 times.
4 times. When running specific AI tasks, including simulations for models like Meta's Llama. And here's the really tantalizing part. The researchers project that with more layers, we can see improvements of up 12 times in performance.
12 times faster, just by stacking components, and I assume it's more energy efficient too.
Massively. We could see 1,000 times improvement in what's called the energy delay product. It's a geometric leap enabled by geometry.
And what's really important here, especially for the U.S. technology base, is that the chip was made in a U.S. commercial foundry.
Critically important. It proved the technology is production ready. It can transition to large-scale, practical deployment quickly. And that is a huge step toward reinforcing domestic semiconductor capability and, supply chain security.
Okay, so a 4 to 12 times improvement that's revolutionary. But then we saw another breakthrough that takes that number and just multiplies it. Photonic computing.
This is where it starts to sound like science fiction.
Yes. The Chinese photonic chip breakthrough. This came from researchers at Shanghai Jiao Tong University and Tsinghua University. And this is a truly different animal because they're moving beyond electrical signals entirely.
Okay, walk us through this simply. For you, the listener who maybe doesn't follow chip architecture every day, how does this work?
In short, it uses light photons instead of electricity or electrons to process data.
Electrical signals, even in the fastest silicon, they generate heat, they generate resistance, and they can only travel so fast. Light, on the other hand, much faster, and it generates almost no heat. The key breakthrough here was eliminating this energy-intensive step of converting electricity to light that plagued all the earlier attempts. They've integrated everything into one highly optimized unit.
And the numbers that our research team flagged they're just staggering.
Truly staggering. The device achieved a demonstrated 100 times GPU performance and 100 times the energy efficiency compared to current top-tier electrical GPUs. Let's say the NVIDIA A100.
100 times.
100 times. And this chip integrates over 2 million photonic neurons on a tiny device, measuring just 1/4 of a square inch.
100 times the performance and energy efficiency. I mean, that doesn't just improve speed, that solves a massive ecological problem, an economic problem.
It is a profound economic disruptor. This is the first photonic chip that's capable of large-scale, complex generative AI. Not just simple classification tasks, but training models for image generation, video creation, high-fidelity reasoning.
Right.
So you think about the enormous energy demands and the carbon footprint of current AI training farms. If photonic computing scales, it could fundamentally alter the entire economic trajectory of the AI cloud market. It would make continuous model improvement dramatically cheaper and faster. The whole cost structure of AI today is built on energy consumption. This changes that denominator completely.
Okay, so we have these revolutionary new chips, but let's talk about the memory that feeds those chips. Because even if you break the memory wall, memory itself can be a bottleneck. Our sources highlighted this fierce competition in what's called high bandwidth memory, or HBM4.
This is a critical infrastructure race. It's primarily between Samsung and SK Hynix, and they are moving incredibly fast toward mass-producing HBM4 memory, which is essential for NVIDIA's next-generation Rubin AI accelerator platform.
And HBM is basically memory that's also stacked.
Yeah, just like the 3D chip, but it's optimized for massive bandwidth.
So what are the metrics here? What's the improvement?
HBM4 delivers double the bandwidth and over 40% improved power efficiency compared to the previous HBM3E generation.
Doubled bandwidth.
Doubled, which means your massive LLMs can access the data they need twice as fast. And that is paramount for inference at scale, the operational phase. So if the 3D chip is the new vertical highway, HBM4 is doubling the number of lanes on that highway.
And this is a big market.
Huge.
Yeah.
SK Hynix, for example, is planning to produce 550,000 wafers next year. It's cementing Korean dominance in this very specialized AI memory sector.
But maybe the biggest strategic hardware move of this period wasn't about a company making their own hardware faster. It was NVIDIA's massive, was it $20 billion licensing agreement for Grok's LPU technology.
Non-exclusive, yeah.
Right, so why would the GPU king who built this empire on training models spend $20 billion on a rival's inference technology? That feels like a massive admission of something.
That is the crucial question. And the answer tells you everything about where the entire industry is shifting. This deal signals that the inference market, the ongoing, continuous cost of running the models millions of times a day, is now the larger, more competitive, and more lucrative battlefield than the training market.
So it's not about building the model anymore, it's about using it.
It's about using it efficiently. NVIDIA is tacitly admitting that the fundamental GPU architecture, while it's great for parallel training, it faces structural limits when it comes to low-latency, high-throughput inference for these new conversational agents.
And Grok's secret sauce is that on-chip SRAM memory, right?
Precisely. Grok's LPU technology uses extremely fast on-chip static random access memory, SRAM. It enables this remarkable speed improvement at the inference stage. By keeping the working memory right next to the processing cores, it basically eliminates the internal memory wall for those specific workloads.
The data doesn't have to travel at all.
It's right there.
So by getting this non-exclusive license, one of their biggest deals ever, NVIDIA is basically future-proofing their business. They're extending their strategy beyond just selling GPUs for training. They're guaranteeing they stay the market leader for operational AI, even if it means integrating a rival's tech.
It's a competitive imperative for them. Optimizing AI inference at scale is the new frontier, especially when you see every cloud provider, Google, Amazon, you name it, developing their own custom silicon. They're all trying to cut out the middleman and run their own models more efficiently. This $20 billion license, it's an insurance policy. It's a strategic declaration that the economics of running AI are now paramount.
Okay, so the hardware is accelerating the physics of computation, making these long autonomous loops actually economically feasible. Now let's turn to what that computational power is enabling, the Agentic Era. You mentioned this is a strategic move from just prompt response to genuine achieving objectives. And the clearest example of this pivot seems to be Google's Gemini deep research agent.
This is really the definitive moment where the AI becomes a proactive worker, not just a reactive chatbot that sits there waiting for your next command. Gemini Deep Research, which is powered by the Gemini 3 Pro model, it introduces what they're calling a high thinking mode.
High thinking mode?
Yeah, it's a computational state where the model engages in this extremely deep, structured chain of thought processing for a really long time before it generates any final output for you.
And the most stunning detail from the research team was this 60-minute autonomous loop. We really have to unpack what that hour of autonomy actually looks like for you, the user.
Well, it's the difference between asking a traditional assistant to look up a specific fact and asking a professional research colleague to conduct complex, multi-layered due diligence.
Okay.
So the user delegates a high-level, complex objective, something like analyze the 5 biggest supply chain risks for rare earth metals in the next 12 months, factoring in political elections and resource depletion models.
That's a task a human analyst would spend weeks on.
Exactly. And the agent autonomously deconstructs that vague high-level goal into this hierarchical tree of manageable subtasks. It doesn't just search for keywords. It identifies all the constituent parts: geopolitical stability, historical refining capacity, recent legislative changes.
It's breaking the problem down.
In real time. That's subjective deconstruction.
So what happens during that 60-minute loop?
For up to 60 minutes, the agent performs autonomous navigation. It initiates hundreds of queries across the open web and any private data repositories it has access to. And crucially, it has the capacity to ingest and integrate multimodal data.
So it's not just text.
Not at all. It can ingest and parse complex, multi-page PDFs. It can analyze graphs. It can even synthesize information from multi-hour video files. All of this is possible because of a massively expanded context window. It acts like a skilled analyst, pulling together data points from all these different sources to find contradictions.
And then it tries to resolve those contradictions.
It does. It initiates new search branches to resolve any conflicts that are flagged by its internal verifiability checks.
And the real technological marvel here, the thing that makes it truly agentic, is the self-correction mechanism.
That's the metacognition piece. It's the thinking about thinking. If a specific search path yields low quality or contradictory or just redundant data, the agent autonomously recognizes that failure. It prunes that unproductive branch of its search tree and immediately formulates an entirely new search strategy.
And this is all happening without any new prompts from the user.
No human intervention whatsoever. And its integration into enterprise environments. It marks this profound psychological shift. Users are now delegating deep, ongoing cognitive labor to what truly acts as a professional-grade research colleague.
But this shift toward autonomous action, it creates a huge structural problem, doesn't it? Interoperability. I mean, if every company builds agents that only speak their own proprietary language, the whole ecosystem just fractures and you're locked into one vendor.
100%.
And that's why the formation of the Agentic AI Foundation, the AAIF, is maybe the most important non-technical breakthrough of this whole period.
I agree completely. The early days of agent development were chaotic, totally fragmented. Company A builds an agent with a custom API. Company B builds one with a different one. The result is just vendor lock-in and a mess of incompatible tools.
So the AAIF is meant to fix that.
Right. It's operating under the Linux Foundation, which is highly respected, and it was co-founded by OpenAI and Anthropic, and then joined by Google, Microsoft, pretty much everyone. The goal is to solve this interoperability crisis before it stalls adoption completely.
So how are they solving it, practically? What are the standards they're pushing that will actually matter to you, the user?
Well, they established two critical standards that our research team flagged. One is from Anthropic. It's called the Model Context Protocol, or MCP. It provides standardized ways for agents to communicate and understand each other's operational status, their goals, their capabilities.
Like a universal translator for AI.
A universal protocol, yeah. The other one is OpenAI's Agents.md standard, which has already been adopted by over 60,000 projects around the world.
So just to make it real, if I build a customer service agent on OpenAI's platform, and I want it to hand off a really complex billing issue to an Anthropic-powered resolution agent, these standards make sure that transition is seamless.
Precisely. They are absolutely critical for ensuring AI systems from different builders can interoperate and share context without any friction. It prevents data format wars, it makes debugging faster, and it allows different platforms to integrate specialized functions. At the end of the day, it's what prevents vendor lock-in and enables the kind of portability that broad enterprise adoption really requires.
It's the unglamorous but necessary plumbing.
It's the grease that allows the complex machinery of the agent era to turn without seizing up.
That makes perfect sense.
Okay.
Now let's look at how these agents are being built more efficiently for scale, starting with NVIDIA's Nemotron 3 family of open source models.
Right. So Nemotron 3 is specifically designed not for single monolithic agents, but for building these multi-agent systems. The kind of complexity you see in that 60-minute loop, it requires multiple specialized AIs coordinating their efforts.
And the research highlighted that this family, the Nano, Super, and Ultra models, uses a hybrid mixture of experts, or MOE, architecture. We've talked about MOE before. The model uses specialized subnetworks for different tasks. How does that translate to performance gains here?
Well, the smaller Nemotron 3 Nano model, which is specifically optimized for reasoning tasks, delivers 4 times higher token throughput and up to a 60% reduction in reasoning token generation compared to its predecessor.
60%? That's a massive cost saving.
It's huge. When you have one agent running, you save money. But when you have a sophisticated multi-agent system where dozens of agents are constantly communicating and reasoning in these loops, that 60% reduction in reasoning tokens, it compounds into enormous operationally critical cost reductions.
Which directly addresses that inference cost bottleneck we talked about earlier, making the models dramatically more efficient during the use phase, not just the training phase.
Absolutely. And this modular approach is directly reflected in a parallel trend we're seeing, these open source skill repositories.
Tell us about these skills. It sounds almost like how software developers load libraries, which is a great analogy for anyone trying to get their head around this.
It's exactly like that in concept. Anthropic, for example, open-sourced a repository called Claude Skills. It has over 50 specialized skill modules, everything from complex document parsing to specific business analysis techniques and coding tools.
So each skill is just a small, self-contained software module.
Yeah, it's like a folder of instructions, API calls, and scripts that Claude can load on demand, but only when the task requires it.
So the agent doesn't have to carry around the cognitive load of knowing everything all the time. It just loads the specific procedural knowledge it needs, executes the task, and then unloads it.
Precisely. It means the base model stays lean and fast, while the agent gains these specialized industrial strength capabilities on the fly. And this fundamentally makes AI assistants less like static models and more like extensible software platforms.
You can customize them.
You can load procedural knowledge and complex workflows on demand. It enhances the efficiency and the specialization of your agents without having to retrain the entire underlying model.
And our sources say OpenAI is quietly following suit with their internal testing, codenamed Hazelnuts.
Yes, the Hazelnuts project is reported to be very similar. It allows users to teach agents new, reusable workflows using these special/command packages. The expectation is that this level of specialization and extensibility will roll out across all the major platforms by early 2026. And that's the moment when agents stop being generic chat partners and become highly specialized, customizable employees.
Okay, let's take a breath here for a second.
Yeah, that's a lot.
It is a lot. The progress we're seeing, on the chip front, the architectural stuff, it's just breathtaking. The physics and economics of AI have fundamentally shifted in just the last few weeks.
It really is not just a technological shift, it's a strategic one. These breakthroughs mean that cost and latency, the two biggest barriers to widespread adoption, are rapidly falling.
But the big question is, what does this actually mean for you? The learner, the professional, the person who's actually going to be interacting with these systems every single day.
And that's the key. How does it land in the real world?
Exactly. And the next section of Tomorrow Unveiled is going to look at where all this research is landing, from climate forecasting to life-saving healthcare diagnostics. But first, if you're finding this insightful and you're watching on YouTube, please take a moment to like this video, subscribe to Tomorrow Unveiled, and maybe even consider hitting that new hype button.
It really helps us reach more viewers.
It does. And of course, be sure to turn on those notifications so you never miss an update on the future. Okay, so moving from the lab bench to real-world deployment. That seems to be the central practical theme of late 2025.
Absolutely. These new agentic capabilities, optimized by the new hardware, they are not hypotheticals anymore. They are becoming operational infrastructure across critical global sectors.
And we'll start with physical sciences, where Google DeepMind made a massive world-altering announcement with GenCast, their new AI weather model. This is huge because weather forecasting has always been the domain of these deterministic, physics-based supercomputer models.
Right, solving incredibly complex differential equations. And GenCast is confirmed through independent review to outperform the world's leading operational forecast systems, like the highly respected ECMWF's Ensemble forecast.
So how does it do that?
Well, traditional models struggle because solving those vast systems of equations requires these enormous supercomputing clusters. And even then, they only give you one possible future outcome, a deterministic forecast.
And GenCast just skips that whole process.
Exactly. GenCast is a machine learning model that was trained on 40 years of global historical weather data. It skips the physics simulation and has simply learned the statistical evolution of global weather patterns. The result is a much faster and much more accurate prediction.
And the performance game is most significant where it matters most, predicting extreme events.
Precisely. The research team noted that GenCast performed up to 20% better at predicting extreme weather events like hurricanes, cyclones, and sudden heat waves up to 15 days in advance.
15 days! That's a huge window.
It's a game changer. And crucially, GenCast provides probabilistic ensemble forecasting, so a suite of potential future scenarios. This allows meteorologists and civil defense teams to estimate the probability of an extreme event. That 15-day window translates directly into saved lives through better evacuations and better resource planning.
And I imagine massive economic impacts, too. Better preparation for insurance companies, more stable operation of renewable energy grids.
Sure. Wind and solar grids rely heavily on accurate 7-day predictions. Global logistics depend on reliable shipping forecasts. This is AI as essential global infrastructure. It's fundamentally changing humanity's relationship with extreme environmental volatility.
Next, let's talk about healthcare and biomedical discovery. This is where AI is showing its capacity to explore, biological design spaces that are beyond human intuition.
The sources highlighted a rapid acceleration across 3 distinct areas here. First, in genetic diagnostics, we have a system called POPI-B. This came from Harvard Medical School and the Center for Genomic Regulation.
And what does it do?
It evaluates genetic variants to distinguish benign, harmless changes from actual disease-causing mutations. It can even predict early versus late life mortality onset.
So this is directly addressing that. that diagnostic odyssey for patients with rare diseases.
Correct. It can shorten diagnostic timelines from years to months or even weeks. It replaces months of human geneticist labor with an AI analysis that can identify the single most probable culprit gene.
And secondly, in synthetic biology, the research from Stanford and the Arc Institute shows AI designing new biological entities we couldn't even conceive of manually.
This is perhaps the most exciting finding. The AI designed synthetic viruses called phages that successfully kill specific strains of bacteria. The system generated 16 unique phage candidates that worked in lab settings. And several of them had these highly unusual genetic structures and mutation combinations that human engineers had previously failed to create manually.
So this is strong evidence that AI isn't just optimizing human designs, it's exploring fundamentally new biological design spaces that our intuition had completely missed.
Exactly. We're stepping into an era where biology is less about discovery and more about design. And finally, just making the work of human scientists faster with tools like CRISPR-GPT.
Okay.
It's an LLM-powered tool that helps scientists design complex gene editing experiments. It generates optimized designs, suggests specific guide RNA sequences, and forecasts potential off-target problems. It streamlines processes that used to take months of planning and trial and error into these rapid prototyping cycles.
That speed up is crucial. In drug discovery, time is money, and often it's lives.
Right. This integration across healthcare diagnostics, drug design, acceleration, it suggests a seismic shift is underway.
Okay, now let's pivot to consumer and enterprise integration. Starting with the immediate, tangible uses, like the Waymo Ride Assistant.
Right. Alphabet's Waymo is piloting the use of Gemini AI as an in-car assistant for its driverless taxis. And the AI is designed as a friendly and helpful companion. It handles all the complex, high-touch interaction that doesn't involve driving itself.
So climate control, music, that kind of thing.
Exactly. Climate control, music selection, providing personalized ride information.
But why is this important? I mean, the car drives itself. Why do you need an AI companion?
It's about humanizing the technology. While the AI never touches the driving function, it significantly enhances the passenger experience. It addresses those common questions and comfort issues, making the autonomous experience feel less sterile, less alienating. It's the difference between a silent robotic service and having an intuitive concierge who anticipates your needs.
Then on the other end of the consumer spectrum, we have Meta's pretty controversial data pivot. This is huge for the digital economy.
This is a massive and, yeah, somewhat fraught expansion of Meta's surveillance capitalism model into the AI age. Meta officially began using data from user interactions with its AI chatbots to inform its advertising algorithms.
So if I have a detailed conversation with Meta AI about, say, hiking trails in Patagonia or how to finance a second home, that data is immediately leveraged.
Absolutely. That conversational data is now treated as a high-intent signal for ad targeting. It might be the most precise signal they've ever had.
Right.
If you ask the AI for advice on investing, you will be served ads for wealth management. It closes the monetization loop on their huge open-source AI investments. The AI assistant effectively becomes the ultimate personalized focus group.
And then you have Apple integrating AI quietly, methodically, and really prioritizing on-device intelligence and privacy. We saw that with the expansion of their digital ID feature.
Apple is continuing its strategy of using AI to cement the iPhone as the indispensable remote control for your life, but while minimizing cloud interaction. They expanded the digital ID feature in Apple Wallet to include U.S. passports for identity verification at TSA checkpoints, and that uses on-device intelligence to securely verify data locally.
And the new order tracking feature works the same way, right? Keeping private data local.
Yes. The new order tracking feature, powered by Apple Intelligence, it automatically scrapes tracking details from your emails, flight numbers, package codes, and puts them right in the Wallet app. It's a highly practical function that leverages sophisticated on-device intelligence locally to preserve your privacy. It really reinforces their focus on utility and trust as a competitive differentiator against the data extraction models of Meta and Google.
And finally, let's look at the enterprise. We're moving from small internal pilots to full-on production deployment.
The strategic pivot from vendors like ServiceNow, Salesforce, and Microsoft. It's just undeniable. They are all making agentic automation the default value driver. Salesforce, for instance, they rebranded their core platform around Agentforce 360, positioning agent orchestration, the coordination of multiple specialized agents, as their primary growth engine.
And Microsoft.
Microsoft introduced Agent 365 as a governance and control layer for deploying internal agents. You see it in the spending. Enterprise spending on generative AI reached $37 billion in 2025, a massive year-over-year increase. And those budgets are increasingly allocated toward these agentic orchestration systems, not standalone single-function tools.
So AI agents included is becoming the market standard.
It is. And it's driving massive industrial change.
Okay, so all this progress, the exponential chips, the autonomous agents, the real-world applications, it's moving so fast that our systems of governance and verification and just accountability,
Yeah,
they're really struggling to keep up.
they are. This is the dual-edged nature of this progress. You've got breakthroughs on one side, and you've got massive societal risk on the other.
I think the most startling revelation of the week was the study detailing this AI slop phenomenon. It's creating a true crisis of scientific quality and trust.
This was a landmark study from Cornell that analyzed over 2 million preprint papers to quantify the early impact of LLMs on scientific output. And the paradox it reveals is genuinely unsettling.
How so?
Well, on the positive side, AI is fueling a global productivity boom. Researchers using LLMs posted 33% more papers on ArcFim, and for non-native English speakers, especially authors from Asian institutions, they saw massive output increases up to 89%. So AI is leveling the language playing field, democratizing science.
Okay, that sounds like an unmitigated good. But where's the inversion, the negative effect?
The disturbing finding is the quality inversion. The study found that in human-written papers, complex writing traditionally correlates with higher acceptance rates in prestigious journals. But in the AI-assisted papers, higher writing complexity correlated with significantly lower acceptance rates.
So what you're saying is the AI is providing this hyperfluent, grammatically perfect, and conceptually sophisticated language that sounds authoritative, but it's just masking fundamentally weak or incomplete or even hallucinated scientific findings underneath.
Exactly. The researchers dubbed this AI slop. It suggests AI is enabling the mass creation of technically readable but scientifically empty zombie papers. And this surge in sheer volume is just overwhelming the existing peer review systems. It's making it harder and harder for editors, reviewers, funding bodies to separate actual breakthrough science from highly fluent but derivative or misleading work.
That feels like an existential threat to the institutional integrity of science.
Oh, wow. Okay, shifting from quality to security, we also saw a deeply sobering revelation from Anthropic about agentic espionage. This is a true game changer for cybersecurity and for international relations. Anthropic disclosed detailed findings of a highly sophisticated espionage campaign that was detected in late 2025. And the attack, which they attributed with high confidence to a state-sponsored group, used autonomous agents to execute complex multi-stage cyber attacks without any human intervention.
We've been talking for a while about AI as a tool for bad actors, but here, the AI was the operator, the autonomous threat actor itself.
That is the critical, terrifying distinction. The threat actors manipulated Anthropic's Claude Code tool, which is an autonomous coding agent designed for benign development, by slightly altering its initial objectives.
And then what did it do?
The agent then autonomously scanned for vulnerabilities in target systems. It wrote custom exploit code to bypass defenses, and it attempted to move laterally within the compromised networks to extract data. This is the first documented large-scale cyber attack where the AI was the primary executive, not just the instrument.
So this confirms the offensive AI thesis.
It does. It confirms that autonomous agents fundamentally change the asymmetry of cyber warfare. It allows a single actor to deploy thousands of intelligent, persistent, and adaptive agents all at the same time.
And this technological leap, it raises the fundamental legal and IP conflict, especially for creative sectors who feel their work is being expropriated for training data.
The legal pushback is accelerating globally. We saw the launch of the Creators Coalition on AI, or CCAI. It was formed by prominent directors, writers, actors, and they are advocating very strongly for two key guardrails: explicit consent and fair compensation when AI models are trained on creative works or digital likenesses.
Demanding clear legal mechanisms to protect creative control.
And prevent deepfake misuse.
And the class action lawsuit against Adobe over its Firefly generative image model shows this fight is really moving into the courts now to set precedents.
It is. Creators are alleging improper use of customer content images, documents, designs that were uploaded to Adobe's platforms to train Firefly, all without explicit permission. They argue it violates copyright and their existing terms of service. The outcome of this, and cases like it, will set crucial precedents for how AI companies globally obtain and use data.
It's forcing the industry to establish transparent, standardized mechanisms for data consent.
And fair use in AI development, yeah.
So finally, let's look at regulation and the tangible human impact on the workforce. Starting with governance, New York State enacted the Responsible AI Safety and Education Act, the RAISE Act.
This is arguably the strongest U.S. frontier AI transparency law that's been implemented yet. It requires developers using models trained with compute exceeding a certain threshold, reported to be about $100 million in training expenditure, to publish detailed safety protocols.
And they have to report incidents.
Right. They have to report safety incidents, failures, or dangerous outputs within 72 hours of detection. And it establishes significant financial penalties, up to $3 million for subsequent violations. This is a direct attempt by a major jurisdiction to manage proliferation and operational risk aggressively.
But this immediate state-level action, it creates tension with the federal executive order and the pending federal task forces, right? It creates a really complicated regulatory landscape.
It creates a complex, multi-jurisdictional regulatory future. State attorneys general are pushing for federal preemption to create uniform standards, but the RAISE Act suggests that some jurisdictions just aren't willing to wait for Washington to act. The big challenge in 2026 will be navigating this patchwork regulatory landscape while ensuring that innovation isn't stifled by conflicting rules.
Right.
And separately, we should note, China also issued draft regulations to govern AI with human-like interaction traits, which signals that global regulatory attention is very specifically focused on these agentic systems.
And we can't talk about all this efficiency without talking about labor market disruption. Our research highlighted a clear disconnect. The productivity boosts are real, but so are the staff reductions.
Absolutely. You have companies like JP Chase reporting up to a 6% gain in productivity from AI adoption. That's tangible. It immediately impacts their bottom line. However, our research also flagged internal planning signals from major organizations like Wells Fargo that are anticipating staff reductions and setting aside higher severance budgets for 2026.
And this is directly attributable to AI.
It is. It's AI-driven automation in areas like software development, legal reporting, and advanced customer service tasks.
The narrative has really shifted, hasn't it? It's no longer just AI augments employees.
It has fundamentally shifted to AI allows us to do more with significantly fewer employees.
Yeah.
And that is the critical economic challenge that policymakers and organizations have to face head-on. As agents become these professional-grade colleagues, the nature of human employment is going to have to evolve very, very rapidly.
So, what does all of this mean? We've reached the end of 2025, and it is crystal clear that we have transitioned from the wow phase of AI, watching it generate a passable poem, to the work phase, watching it conduct complex autonomous research, design new drugs, or manage global weather patterns.
Right.
The competitive edge is no longer who has the biggest model. It's who can achieve maximum efficiency, maximum safety, and maximum integration at the operational level.
And if I had to synthesize the vast amount of information our dedicated research team compiled into 3 key takeaways for you, the listener, they would be these. First, hardware is finally catching up to the models. The breakthroughs in monolithic 3D chips promising 4x to 12x performance, and the photonic chips promising 100x efficiency. They are fundamentally solving the physical limits that have constrained scaling. The economics of AI are changing because the memory wall is collapsing, and that makes everything else possible.
Okay. And second, the agent is the future, and it's driven by efficiency and standardization. That shift from reactive chatbots to proactive agents that can achieve these complex, long-duration objectives epitomized by Google's 60-minute loop, that's the new standard. And critically, the non-technical standardization work from the Agentic AI Foundation will rapidly accelerate enterprise deployment, making agents the default way organizations interact with intelligent systems.
And third, governance is the new frontier of risk. While the technical progress is immense, the industry's ability to capitalize on it hinges entirely on solving these critical governance challenges, combating AI slop, managing the asymmetric threat of agentic espionage, and establishing clear, workable regulatory guardrails. That's the only way to ensure utility and maintain societal trust in these increasingly autonomous systems.
And looking ahead to 2026, we expect to see the continued acceleration of edge AI. That's going to be driven by efficiency breakthroughs like BitRL Lite and Litter Tatter. which will democratize where intelligence can actually run. And the narrative, I think, will fundamentally shift from theoretical potential to proven results as these AI-designed biotech drugs move into critical clinical trials. That shifts the focus to proven medical outcomes, not just laboratory potential. If you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It truly helps us reach new listeners.
And we love hearing your thoughts. Whether you're on YouTube or your favorite podcast app, leave a comment and let us know what you think about the rise of autonomous AI agents and what that massive labor market shift means for your industry.
To leave you with one final provocative thought based on the sources, if highly intelligent one-bit models can now run locally on microcontrollers and simple ARM processors, will the most important AI developments of the next year happen not in the massive centralized cloud data centers we talk about so often, but quietly inside the devices that are already surrounding us?
Something profoundly interesting to ponder as we move deeper into the agentic era.
Thank you for joining us for this deep dive on Tomorrow Unveiled. We'll see you next time.